Hello and welcome to this video on matrix proof. So firstly, here's some information I found on Save My Exams, which is very useful. So firstly, what matrix relationships do I need to know? Well, you need to know that A times A minus 1 is given by the identity matrix, as is A minus 1 times A. And you also need to know that if you find the inverse of AB, that's the same as the inverse of B times the inverse of A. Then how do I prove matrix relationships? Well, there's a couple of terms here I'm going to be using: pre-multiply and post-multiply. So when we pre-multiply, whenever we're multiplying by on both sides, we write on the left-hand side of each side of the equation. And if we're post-multiplying, we write it on the right-hand side at the end of each side of the equation. So let's start by proving that the inverse of PQ is given by the product of the inverses of Q and P in that order, where P and Q are non-singular matrices. So what we're going to do is we're going to let M equal the inverse of PQ, and then we're going to show via a series of steps that M is also equal to the inverse of Q multiplied by the inverse of P in that order. So starting with the fact that M equals the inverse of PQ, if we pre-multiply by PQ, we get PQM is equal to PQ times the inverse of PQ, which on the right hand side, that will just be the identity matrix. So PQM is equal to I. Then we pre-multiply by P minus 1. So P minus 1 PQM equals P minus 1I, which just equals P minus 1. And on the left-hand side, P minus 1P is the identity matrix. So we get that QM equals P minus 1. And again, we pre-multiply. So Q minus 1 QM is equal to Q minus 1 P minus 1. The right-hand side is what we want, and the left-hand side simplifies to IM, which in turn is M. So M is equal to the product of the inverse matrices of Q and P. And now, given what we've just proven, we've now been asked to prove that A times by BC is the same as EB times by C. So given what we've just proven, we've been asked now to prove that A times BC is the same as AB times C. And we're going to start in the same way by calling the left-hand side matrix M. So M is equal to A times BC. And we wish to prove that it also equals AB times C. So in step 1, we pre-multiply by the inverse of A. And as a result of that, on the right-hand side, the inverse of A times A is I. So in step 2, the inverse of A times M is equal to BC. Then for step 3, we pre-multiply by the inverse of B, which gives us B minus 1 A minus 1 M is equal to B minus 1 BC. B minus 1 times B is simply I, which therefore the right-hand side is equal to C. In step 4, we pre-multiply by AB on both sides. So we get AB times the product of the inverses of B and A, multiplied by M, is equal to what we want, AB times C. And then focusing on the left-hand side, the product of the inverses of B and A is also given by the inverse of AB in step 5. And in step 6, AB times its inverse is just I. So step 6 says that IM is equal to what we want, AB times C, and hence M is equal to AB times C as required. So A times BC is the same as AB times C. This next proof comes from chapter 6, example 16 in the textbook. And we've been given that BAB is equal to I, and as a result, prove that A is given by the square of the inverse of B. So for step 1, I've just written down what they've given us, that BAB is equal to I, and in step 2, I'm pre-multiplying by the inverse of B. So on the right-hand side, we just get B minus 1, because it's B minus 1 times I, which is B minus 1. On the left-hand side, the B minus 1B gives us I. So in step 4, we have that AB is equal to B minus 1. And then we post-multiply by B minus 1. So in step 5, we've got AB, B minus 1 is equal to B minus 1, B minus 1. On the left-hand side, B minus 1 is I. So we have AI is equal to B minus 1, B minus 1, which in turn means that A is equal to B minus 1, B minus 1 as required. Here's another proof to work out. Given that ABC minus 1 is equal to I, prove that B is equal to the inverse of A times C. Please pause the video and have a go. And here's my solution. So Pre-multiplying by a minus 1, we get that bc minus 1 is equal to a minus 1. And then by post-multiplying by c, we get that b equals a minus 1, c as required. This is question 3a from exercise 6D. Please pause the video and have a go. And here is my solution. Please pause the video and have a read. This is question 5a from exercise 6D. Again, please pause the video and have a go. And again, here is my solution. And finally, here is question 9a from exercise 6D. Please pause the video and have a go. And here is my solution. Thank you for listening.